Hi everyone, welcome to our channel Code with Sunny, and today I am going to discuss the problem Roman to integer of Leetcode. Index number is 1313 and the problem is of easy type. Okay, so let's jump directly into the problem statement. In this problem, basically, according to the name of the problem, you can also understand that we will be given a string that is actually denoting the Roman form of an integer, and we have to convert that string that is in Roman form to its integer value. Suppose let's move to the example. Suppose it is given s equals triple I. So we all know that this is actually representing the value 3 in what integer form, and this is string s, and this is in what Roman form. And similarly this will be denoting what 4, and similarly this will be denoting 9, and there is a table of entries also. You can understand this also. Suppose we have to write 12, then what we are going to do is first we are going to write 10, that is x, and then we are going to use 2, that is for the remaining 2 which is left in the 12. Then I am going to use 2I, denoting that I have covered up 12. Similarly, suppose I have to write 75, then first I have to write 50, that is L. Then I have to write to 20, that is then I have to do I have to append 2x, that is x, then our answer would be like L x x. Then you note that we have covered the value 70, then I have to cover the value 5, then I have to append 5 to my answer, which would be our Roman string. So how I am going to convert the given Roman string into integer? Okay, so let's move on further. So first I am going to discuss the key observation that is very much what pretty much useful here. Suppose let's say we have the value 3, then note that 3 can be written as 5 minus 2. Okay, this is the main observation here. Note that 3 can be written as 5 minus 2. Again, suppose I have the value, or we can say suppose I have the value 4, it can be written as 5 minus 1. First I'm going to discuss why I'm going to use this. And again, suppose we have to say we have to write 9, then we can write it as like what? Oh, I want my viewers to think upon here. Okay, so we can write 9 as what? 10 minus 1. And suppose now the key observation is, suppose you have to write 7, then how we are going to write? I am going to write 5 plus 2. Okay, so the only main thing that is creating problem is, you can see how I am going to determine the minus sign, how I am going to determine the plus sign. That is in case of 7 I am using 5 plus 2. In case of what 3, you can see I am using 5 minus 2, and in case of what, let's say I have 8 here also. So how I am going to use? I am going to use 5 plus 3. Why I am going to use 5 plus 3? Why not 10 minus 2? Because I am going to use 5 plus 3 because this is giving this is a pretty much key observation in our what, in our approaching this solution. So if we write, let me write now, if we write the what Roman form of 3, you can notice that it would be like III. So this is what denoting 3. So you can write 3 as what, 5 minus 2. Similarly, I am going to write 4, this is I V. Note that here there is a single 1, single I. That's why I am going to write 5 minus 1. That is forward is going to represent V. That will be 5, and similarly 1. Okay, for a single I, and again 9 would be like IX. So why I am going to write Ix? Why not 5 plus 4? Because we all know that the Roman form of 9 is Ix. Then how we are going to fetch this Roman form? The best way to fetch this Roman form is to write like this. That is 9 can be written as 10 minus 1. That is forward is going to represent x, and 1 is going to represent the single I. And similarly, if we write 7 as VII, we all know that 7's Roman form is VII. Then you can notice that I am going to write, I am not writing here 10 minus 3, because if we write 10 minus 3, our binary representation would be like what I and X was, but this binary representation is what wrong. So I'm not going to use this. Why I'm not going to use this? I'm going to use this value, that is VII. And similarly, if I 8 for 8 binary representation, we are using what? VIII. Okay. So one thing that is pretty much clear here. Suppose I have been given, let's say, X V I. Okay. So let's say this value is around what? This value is actually 48. Okay, so how I'm going to build up this 48 number? So let me write. Suppose let me write first table of entries. Okay, that will be much clear. That is this one. Okay, that is IV Excel CDM. Okay, I'm going to write here first. Okay, so first users I is going to denote 1. Similarly, V is going to denote 5, and then similarly X. Okay, X is going to denote 10. Similarly, L is going to denote 50, and similarly C is going to denote what? 100. Similarly, D is going to denote what? Let me see for clearance. 50, and M is going to for 1000. 50 and M is going to denote for 1000. Okay. So this is pretty much our table of entries. So if you have been given XV triple I, so what I am going to do is, if you observe this pattern, this keen observation clearly, you can solve this problem in most efficient way. So consider the adjacent numbers, that is, let's start from the index equal to 0, and if we consider the adjacent numbers, that is, here you can see XV. So if we consider the XV only, and consider the value from the table of entries as defined above, that is, X value is 10 and V's value is 5, then what I am going to do is, if let me write, if value of, let's say, current, what, if value of current is going to be what, less than or equal to, if value of current is strictly less than, let me write here, value of current plus 1, then I'm going to do subtract operation. Subtract operation from what? Let's say I have an answer variable here defined above. Let me write. Okay, answer variable defined above as 0. Okay, so if a value of current, that is, here you can see I have a value X, that is what, 10 values, and V, that is what, 5 values. If 10 is less than 5 but it is not here, so I'm going to do otherwise add operation. So if 10 is what, 10 is greater than 5, so I'm going to do add operation. So I'm going to add 10. Then again, if we, that is what, if current value V is going to be greater than I, then I am going to do what? Know that the V's value is 5 and I's value is what? 1. So if V's value is going to be greater than what, I's value, then I am going to do what, add operation. So now I am going to add 5, and then again, if I's value is going to be what, greater than I, sorry, it is 1 is 1, 1 is less than 1, so false. I am going to do add operation here. That is 1, and again, if 1 is also always less than equal to 1, this condition goes false, so now I am going to again add 1. And then finally, for always last character, always I am going to do what, perform the addition operation, because there is no next character. So this would be what, 15 plus 3 18. So this would be our 18 values. So if I had mentioned 48, sorry for my mistake, this value is 18. So this is giving the correct result. So this is our key observation. If adjacent character value, that is value of current, is less than value of current plus 1 from the table of entries, it is best way to subtract, and otherwise we have to do add operation. Let's take another example. Okay, what will be our another example? Let's say we have the value 19. Let's say I can write XIX. Okay, so if from the table of entries, let's start from the adjacent values, that is xi. The value of x is what? 10, and value of I is what? 1. Okay, then I am going to do is what? A value of x is 10. 10 is what? Greater than I. Then I am going to do add operation. So I am going to add 10. Now I is less, i's value is 1, x value is 10, then it is what? 1 is less than 10, so I am going to do subtract operation. So our subtract operation would be like subtract the value 1. So I am going to do subtract 1. And again for the every last character, there is no next character, I am going to always add its value, that is 10. So if we call this as, then you can see it is 19. So our observation is pretty much clear, this formula. Okay, so let's move on to the approach. So check every adjacent character, that's what I am going to do. Always maintain a table of characters and its value. If next character value is strictly more than the current value, then I am going to do the okay then next character value is going to be more than the current value, then always perform subtract operation from the current answer variable. Otherwise I am going to do addition operation. For the last character, always perform addition of its corresponding value. Why? Because there is no next character, I need to append that value, then I am going to print the answer variable. So time complexity goes to O of n. Okay, so let's move on to the code and check out the implementation. So what I'm going to do, there is a table of entries IV, XL, LC, DM, and their values in an unordered map, because this will make our code somewhat faster, or you can say, or I'm going to iterate in the string. Note that I'm going to iterate till length -1, and if the current value entry, that is current table entry, that is value of that current character is going to be less than the value of the next character, then I'm going to do subtract operation, that is subtract what? From our answer variable. I have note that I have initialized answer variable at 0, and because I'm going to build up the answer. So let's start build up the answer from 0. And if this is not going to hold, I am going to add the current character value. Note that always last character value is going to be added, so I am going to add that, and finally I am going to return the answer. So let's submit this code and check out. Yes, it is faster. So if you have any doubts, do not forget to mention in the comment section of the video, and the link to the code is mentioned in the description section of the video. And I will ask the viewers to like this video, share this video, and do subscribe to my YouTube channel, and also join my Telegram channel mentioned in the description section of the video. And thank you for watching this video.